So I am here, Michael talked a bit about the PEDSnet data quality in his talk. I'm here to kind of give an overview of what we're doing, how we evolved, and how we have worked with data quality in our network. And later, Connor, who is also here, will actually walk through the actual steps of implementation. So PEDSnet, what is PEDSnet? We began from the PEDSnet initiative where we're clinical data research networks, and we are 8 children's hospitals, and we use data from electronic health records. The purpose is to facilitate large-scale research, participate in PEDSnet, and do our own learning health network, clinical epidemiologic studies, anything that you would use good data for. Our PEDSnet data flow, so as I said, we're 8 and expanding and kind of situating ourselves. All of our sites perform a ETL data, so quarterly they pull their data from their electronic health records, standardized to OMOP, and then we receive that at the Data Coordinating Center. And from the Data Coordinating Center, which is where I work, I probably should have started with an introduction to myself, but I work in the PEDSnet Data Coordinating Center. And then there we do all of the data quality, we do query fulfillment and data modeling activities and things like that. And we also participate in PEDSnet. I don't know how many of you guys are familiar with PEDSnet, but it's a different data model. We prefer OMOP, so we do both so that we can participate in PEDSnet but still keep our own network. And from there, with our sites, there's a lot of interaction in terms of meetings and GitHub and communication, and also participation in the network as well. We're not the only ones who can use the data for fun. So given that background, our PEDSnet DQA kind of started as a necessity. As we were receiving data from sites, we just needed some way to think about just making sure everything was okay. We didn't really think in terms of a framework. It was very applied, and we need something now. So we literally started with just thinking about missingness. I guess we're glass half empty, we don't say completeness. So we're looking at percent missingness in all of our sites, and we kind of color-coded based on, so this was the OMOP person table, and so we were thinking to see what the percent missingness was in each important field. And this is kind of the beginnings of how we began to think about data quality. So then, as we started to evolve and as we started to think more about data quality and how we can improve, and as we also began so the first part of the network was just getting set up. So a lot of the work that we did was just getting a network infrastructure. And then when we actually started querying it, we realized that we probably need to do a lot more with data quality because clinical data is pretty messy. So the things that we started to consider when we began thinking more deeply about our approach, Michael had mentioned we have this huge conventions document that we keep and that we use to interact with sites so that everything is specified. We have what each field is supposed to mean and provide guidelines so that standardization can be easier. Data requests, so for example, we never thought we would focus so much on provider specialty, but that turned out to be a huge thing because that is what investigators and people who are using the network found very important. So that was that's a driving force in terms of helping us frame what we want to focus on in data quality. And then, of course, the theoretical general standards. Michael's paper was very big, it was very important in terms of helping us frame how we are tagging and thinking about data quality. Anticipating conformance with other research networks. Like I said, we participate in PEDSnet, so that was a big thing. And then anticipating needs for PEDSnet. Where are we going and how should we frame our data quality to do that? So as I said, this was a very pragmatic approach that we took. And so it kind of, what we started was creation of a whole bunch of checks, and then we kind of stepped back and said, okay, now we need to actually think about organizing this in some way. And so that led to our PEDSnet DQA catalog. And so here we list all of the different kinds of checks that we're doing. And so, I just highlighted as an example, there's nothing crazy, like there's nothing inherently important about the future event check, but that is something that we think is important to check, and then we apply that check to different fields. Like visit start date, for example. If there's huge future events, if there's something like 20 years in the future, we would flag that. So we look at these different checks, think about how to apply it to the data model, set those thresholds, and then apply those checks in a systematic way every time we receive data from our participating institutions. So you can see in the output, and Connor will go through the actual steps and give more examples in terms of output, but this is kind of how our check, so the B001 is the missing data check type. We applied it to admitting source value in our data model, and we found, in this particular site, it was about 94.84% missing. And so that's kind of how we are cataloging and thinking about our checks as it applies to different fields. And then this is the output when there's an issue that's raised, when there's something to be looking at. We produce this kind of output in CSV and think through, is this real, is this not? And we're constantly tweaking our thresholds, because it could be, for example, 1.73 might not be a big deal for missing. And so the thresholds, I think, are probably one of the most important things in terms of thinking about data quality. So as I said, our approach is very pragmatic. Our input is the site level data, and our output, what we get from it, we have right now kind of two different types of output. We call them level 1 and level 2. The first one is just univariate distributions. So a lot of it is these, if we're looking at missingness, looking to see missingness in a certain field, or just distribution of values of fields. Level 2 is kind of where our issues and where the problematic things get generated, and feedback is given to sites. We are primarily, everything is in R. There's a couple of short programs that we've used Go and Python, but we're, I think, in the future trying to integrate everything into R. But one of the features, for example, is that when a site gives us data for a quarter, and then we talk through it, and it turns out that that's just the characteristic of their site. We flag that, and then so that next time that same one doesn't get flagged for the site, so that they aren't constantly saying, "I told you last time." It's just the characteristic of our data, and so that's what the Go program is for. So the output, so the way that, and again, this is totally because of our pragmatic approach, the format that we have been giving the feedback for data quality has been completely on GitHub, so that we raise the issues and they're seen as GitHub issues, so that sites can actually look at those in their technical work and be able to respond to them. We don't have, a big grand report yet, or anything like that, but it's flagged issues in GitHub. And so we're right now trying to fold in kind of some site-by-site comparisons, and so that sites could, because right now everything's just issues within each site's individual repo. So some of the features that we've put in, we've been ranking issues so that when something comes up for sites, they can look and say, okay, this is considered high priority, so I'll focus my attention on that first. And because we're using GitHub, we are constantly in communication with our sites to be able to figure out what the source of the issue is and why. And then we actually use the GitHub labels to say, okay, this causes provenance, this causes an actual programming error, and then we store this information over time.
Can you say a little bit about who we, as you talked about how
Yeah.
we're thinking about these things, so within which institutions, and then who's participating and how the feedback goes out?
Yeah, sure. So the sites, like I said, we're 8 children's hospitals, so they all give us their data. Actually, 6 sites give us their data, 2 keep it remotely. So they actually have to run the program themselves and kind of generate the feedback themselves. But for the sites that decided that they were going to send their data to the Data Coordinating Center, which is in CHOP, we run the program ourselves. So we, Connor, and the Data Coordinating Center, led by Dr. Charles Bailey, and we all kind of have participate in it in different ways, whether it's providing feedback to the sites. We regularly in our meetings, our team, and I have an acknowledgements page, but the Data Coordinating Center, we go through the different issues sometimes, think about how we're going to prioritize things, what are the next steps for data quality. And so it's been very, very collaborative, and Connor has really, and I should say, and I have, again, in the acknowledgements, Ritu Kare, who's no longer at CHOP, she accepted a position somewhere else. She really pioneered this program. And so we're kind of picking up where she left off. And so the GitHub issues, again, when we just provide the feedback, it's going back to each site's ETL analyst, and then the DCC responds and says, okay, you got to check this, you got to check that, and we close the issues, we provide the labels. This is all done within the Data Coordinating Center. Does that answer your question? Yeah. Okay, good. So I kind of talked through, this process, but their data quality checks, they're applied, data quality issues are generated, and then what we call is the data quality issue warehouse, which is just, right now, a bunch of CSV files on GitHub that we're trying to organize a little bit better. But we identify the causes, post the feedback, and then that's when a lot of the interaction happens with the site ETL analysts. So this is an example of some of the feedback. So for this one, this is the first part. That's kind of our level 1. This was the gender concept idea. I know it's a little bit small. Sorry about that. And then we apply rankings for different fact tables. And so this is just an example of the visual report that we have. And again, Connor will go through and show you some more of the concrete output. But this is actually, when we say we generate issues for sites to respond to, this is kind of exactly what it looks like. So this was done February 2018. One of our findings was unexpected change in the number of records between data cycles. We write the finding, and then the person says, okay, well, this is an ETL error. We're going to get it we're going to fix it for next time. So this is just an example of some of the back and forth that happens as we generate data quality issues. And so some of the output that we've had, the data quality, it's been very interesting to watch. As we you can see the places where there's data model changes, and then the number of issues go straight up right after that implementation. So every time there's a data model change, we look to see if that's being applied correctly, and then generate the output. And this is in our latest release, kind of a distribution of where data quality issues are being generated. So drug exposure, sorry, I forgot. So the other bar that you're not seeing, the gray bar, is the v3.0 release. So this is in comparison to last time, where issues are and where they're being generated. And then the check type distribution, which one, the invalid concept IDs, missing data still continues to be a big, big problem. And then the rank and cause distribution here. So as we are ranking, and we're trying to automate this as well, and Ritu started a machine learning program that would automatically assign whether something is high, medium, or low, or whether something is an ETL or characteristic issue, and we're trying to roll that in as well so that it doesn't have to be quite so manual and rule-based at this point. But for now, as we go through and kind of assign rankings, what we are seeing as high ranked issues tend to be the ETL, things that we can fix, and that's where we think it makes the most sense for sites to spend their time, clearly, so that they're able to focus their efforts. So while over time programming errors have decreased, we're trying to still focus on the ones that we can fix. So where are we headed? Right now, I think, are trying to make things a little bit more streamlined, more automated, because right now, you have to run this, and you have to run that, and then you have to think about the Go program, and then look at the output, and there's a lot of steps that we just like to have more streamlined. Because we have worked primarily with Postgres, everything has been made with Postgres in mind, but now we are trying to expand our horizons and work and try to make it more compatible with other DBMS systems. Right now, so what we get are issues that are generated, problems with the data. What we'd like is more kind of a data characterization approach, kind of seeing, well, what is in your data besides just what we find problematic. And then from that is to be able to then create a system where the data quality can actually be queryable, that we can say to a site, like, here's what we found in your data characterization, and if someone at your site or someone that you work with receives a data set and they're interested in saying, well, I wonder what all the problems are with the drug exposure table, they can actually query that and see what comes up as issues and see how they can roll that up. And this is kind of a pipe dream for me, but I'd really like to get there. And then what we're calling kind of semantic data quality, which is I think what Michael calls plausibility. We've focused a lot on completeness and conformance, and now we are taking a step back and thinking, okay, well, does this data actually make sense? And so we are thinking about ways to do that. And we kind of, because of the way that we work in our network, we're constantly thinking, okay, what's the informaticist view? What do the ETL analysts care about at the site in terms of how to pull their data better versus the researcher's view? So the informaticist view is, does the data conform to the data model? Is it accurate in terms of pulling what was actually in the source data? The researcher's view is, but wait, does this actually make sense? How is this data plausible? And so it's this constant, trying to balance how we create these checks, and I think this is a really important kind of guiding principle in terms of how you develop the checks, which ones you focus on, and where you go with that, and who you're trying to create the data quality for. And so the acknowledgements, I call the data quality pioneer, Ritu, who really set everything up, and she did an incredible job working through it, and she has moved on. She works at IQVIA now, so unfortunately couldn't be here, but she really developed this whole system, of course, under the guidance of Dr. Charles Bailey, and the rest of the Data Coordinating Center, and of course, all of the PEDSnet sites. I can't tell, as they've patiently waited, as we get through working through the bugs and sometimes flag things at their sites that they're just kind of like, I told you for the 500th time, this is not a problem. So thank you to all of them, of course, because this is totally a collaborative thing, and of course, patients and families. Thank you.